Hello, everyone, and welcome to session 30 on Saturday, room 355 DEF. If that's not the room you're supposed to be in, there's still time to leave. But you won't want to leave because we have a great presenter coming today. We have GraphQL, the devil's API. And the presenting will be the formidable, the unstoppable Ryan Kuhl.
All right, post-lunch crowd. I hope you are not too tired. There's gonna be no falling asleep in this talk, all right? Welcome. My name's Ryan. I'm so excited to be here. This is my first PyCon, and I get to be on stage and for a 45-minute slot. Oh my God, there's tears coming out of my eyes. I'm super excited. I am a senior software engineer at Tatari. We're based out of New York, LA, and San Francisco. And we're gonna be talking about GraphQL today. All right, here's a quick outline for our talk before we get rolling in earnest. So first off, we're going to talk about what is GraphQL. Then we're going to go over a brief example of using the query. We're going to visualize what a GraphQL graph looks like to understand more of how the queries are shaped. We're going to build ourselves a GraphQL server in Python. Let's see, after that, we're going to do a little bit of performance testing. You're going to have to act surprised. It's going to be pretty bad. And then we're going to do some performance optimization, which is the real meat and potatoes of this presentation. We're going to head into conclusions after that with the good, the bad, and the ugly. Show off some open source contributions, and profit will befall all of you. All right, so what the heck is GraphQL? GraphQL is three things. It is an undirected graph, which you can see in their logo. It is a query language. It is a schema, an API, and for some portions of time was the bane of my existence. All right, so let's visualize what the graph looks like. So up top in purple, we have our root node. This is going to be where all queries enter through. In this example specifically, we're going to enter through our root node, and you only have one place you can go. In reality, there's sort of going to be lots of top-level nodes. I'm just really bad at Photoshop, so this is the best I could do. From there, we have the little green connections, which we're going to call edges. Those are going to be what connects nodes together. It's going to be how we traverse our graph. And then the nodes themselves are going to be the data that we want to get. They're going to be related to generally models in our database, but not necessarily. They can really be anything. So let's visualize a quick query. I'm a huge car guy, a huge car nerd, so naturally it's a car analogy. Up top, so we're going to start our query with cars. We're going to say like, hey, we want a list of all the cars. Then we'll go down to brand, maybe Dodge, for instance. From there, we can go to models. You know, you got to have your scary models. You got to have your Dodge Demon, your Dodge Hellcat, and we can look at the engines, right? So in this example, say one model is a hybrid, so it'll have an electric engine and a gasoline engine, which is why the connection connects to two separate nodes. Where the other one, maybe it's just a gasoline engine, so it only connects to one node. So that's how we show our relationships, and we can show one-to-one relationships, one-to-many relationships, and many-to-many relationships in GraphQL as well. All right, our query language. This is going to be what our clients see. This is one of the biggest selling points, in my opinion, of GraphQL. It's a beautiful, descriptive, dense query language. So if we look here, I'm querying evil cars, naturally. So at the very top, you know, we can enter through brand. So I've specified Lamborghini here as a query argument. From there, we can filter based on models. So I'm looking at the Diablo here. We will traverse our edges in our nodes down to engines, and down to availability, and most importantly, we can see, you know, our database model will certainly have like cylinders in our engine area, but is it evil? That is what we'll look at next. Some important pieces to look at in this query first are the highlighted bits. So the highlighted bits specifically are going to be our nodes. So this is how we're traversing through our nodes. And in addition to that, just really take in how much information this single query is extracting. This could be equivalent to 3 or more queries in a REST API, especially if you're trying to limit the amount of resources you're using. Like one query would be like, give me all the makes. The next one would be, give me all the models for this make, and so on and so forth. Some nice things that GraphQL gives us for free in these queries also is that it's type safe. GraphQL operates in JSON in the back end, so any of the JSON native types are completely available in GraphQL, and if you're using a complex type in Python, like something akin to decimal per se, it'll return it in a string format, but the documentation will say it's a decimal, it should be converted to a decimal on the client side. We also get a couple freebies here, which I'll go over very briefly now, but we'll go over a bit later as well. We get some pagination features like cursors, first, after, and we also get type names so that we can decompose the response from this query on the front end. OK, so I hear yourself asking, why edges and nodes? It's so much cruft. It goes so deep. There's so much nesting. Oh my god. Well, first off, I'll say to you, you don't necessarily need edges and nodes. It depends on the schema. You can connect directly. If we look here, between brand and model, that's connected directly. But if you connect with edges and nodes, it gives us the ability to paginate. So highlighted here, you can see first 2. So this is saying of all the models that are Diablo, select the first 2 out of the list. We're going to have has next page to determine, do we need to paginate this? Do we need to run a secondary call with the cursor to get more results, say to fill out a timeline or a list? And after that, we also can get cursor in the edges, and that tells us exactly where we are in the ordered list. OK. So that'll be the extent of the query side for now. We're going to be going to the schema side. So this is all going to be written in Python. This is what our APIs are going to be serving up and how our APIs are going to communicate with our client. So we can see that we can instantiate nodes and connections in here. And mainly what we're doing is we're hooking into our SQL Alchemy models, and we're showing those to our user as nodes. That's all going to be done through the SQL Alchemy object type, and in this example, that's done through a package called Graphene SQL Alchemy. From there, we can add our own properties to this schema class as well. So the isEvil Boolean, which is strongly typed, I'd like to point out, we can add that as a custom property. The only thing we need to do is to tell GraphQL, what do you do when somebody calls that? That's going to be our resolver. The nomenclature here is that the property is called isEvil or whatever, you could call it foo. The resolver method name has to be resolve underscore foo, resolve underscore isEvil, something like that. That's how they connect. From here, the resolver will have access to self, which is going to be an instance of our SQL Alchemy model. So we can hook directly into that to see what's our model name. Is it Diablo? If it is, it's very evil. OK, pit stop from here. I think we're making a lot of headway. We need to talk about 3 things. From the bottom up, we need to talk about our database, we need to talk about our ORM, and we need to talk about our GraphQL libraries. So let's talk about our database first. The really nice thing about GraphQL, in addition to the other wonderful things, is that you can use any database to power it. In fact, it doesn't even need to be a database that's powering it. I've talked to somebody who was using it as a facade over a legacy REST API that they were trying to discontinue. So it's this wonderfully flexible tool that allows you to just place this very simple facade on top of whatever data you want and put it into graph-like notation. That includes, you can use something like Neo4j, which is a graph database. I'm sure it'd probably be easier than if you're using a relational database and trying to make it look like a graph, but I haven't personally used it, so we can move on from there. Next, we're going to talk about our ORM. In this example specifically, we're going to be using SQL Alchemy. In my experience, that's sort of the industry standard, especially if you're using like relational databases. I'm curious about Peewee. Sounds super cool. Sounds a little bit more minimal. but I haven't used it yet, so I think I'm going to hold on to that for my, my PyCon 2023 presentation. Come back soon. All right. Lastly, we're going to talk about our GraphQL libraries. We have sort of two libraries competing for most of the attention. We have Ariadne, which is from the makers of Apollo, which is going to be the most popular GraphQL client on the JavaScript side, so the client side. It seems a little bit newer. In practice, we at Tatari use Graphene, and I think it's pretty much the industry standard. It's got great documentation, good support, and it's named after a super cool, very rad, game-changing material. Okay, a little boilerplate to get us started. Don't go too cross-eyed with this, all this code. This is mainly just saying we're going to set up some models. They're going to be in SQL Alchemy. We're going to init our database so we can have a session, yada, yada, yada. Here's the meat and potatoes of our models. We're going to have a company model. We're going to have a department model. And after this, we're going to have an employee model. One company can have many departments. One department can have many employees. You can see that, for instance, in line 42 through 47. That's going to be our relationship back to the parent model from the child model. Here's what our employee model looks like as well. Again, they're all pretty cut and dry, very simple. They have an ID and a name, and we'll move on from there. This is the interesting stuff. This is our Graphene schema. So if we want to keep it super simple, super minimal, if we just want to expose what's in our database model, then our models can look just like this. We're going to use, again, the SQL Alchemy object type so that our Graphene schema can hook directly into our SQL Alchemy model, do some introspection. And we do that in our meta class, as you can see up here. We also need to say what our root node is going to be. So here we're saying that our root node is going to have companies available, departments available, and employees available at that top level for our users to query through. This makes the API very flexible so that the users don't particularly feel like they're on rails. You can let them sort of discover what they want from the API and fashion it in any way that they want. From here, we just need to make our Flask app so that we have something to query. And that's pretty straightforward. As long as we're using Flask GraphQL, which is another wonderful package, we can just hook our root query in using graphene.schema, say that the schema is the schema in our app, and away we go. We have we have a Flask app, and that means that we have a live demo. Oh boy! All right, let's see how this goes. I hope everybody can read this okay. I know it's a little bit small, but there's a lot of information to go through. Okay, so on the left side over here, we have a GraphQL client, a query client. It's called Insomnia. I highly recommend it. I think it's super slick. It's sort of like a freemium model, and it's very powerful, has autocomplete. You're going to love it. Definitely give it a try. On the right over here, we have the GraphQL app, sort of very similar to what we just saw. I want you to pay particular attention down here to our console. You're going to see some console logging output, and that'll be a little bit of intuition on what's going on. So let's get started. We have like two entryways into a GraphQL API. We can do either a mutation and blah, blah, something like that. And that'll be akin to like a put or a post request for a typical API. The one we're going to go through today is going to just be a query, which is akin to a GET request. And we're going to call it my PyCon query. All right, let's get cruising from here. So let's follow directly that sort of lineage from companies to departments to employees. So if we start up here with companies, we'll see it auto-completes. That's one of the nice parts of schema introspection. And we can go on from here. We have some interesting stuff here that's being completed, but I don't really know what that means as a new user. So I kind of want to learn what this API looks like. What do I have available to me? So in here, I can go show documentation. This show documentation is not specific to Insomnia. Every GraphQL client is going to have it, but it's super helpful, and I would highly recommend it. So if we go back over here, this will be our home page for the documentation. we can go and we can look at our root query. What does our root query have? We have a node down here, which we're going to ignore for now. And then we have companies, departments, and employees. And we can see the type of each one of those, which is a company QL connection, department QL connection, and employee QL connection, respectively. We can also see that there's some sort operations we can apply, and there's some other arguments that we can use too, which are before, after, first, and last. Those are all based around pagination. So let's look what we're going to be querying. So we go into company. We can see that it's going to be a company QL connection type. That's going to give us an edge, which has page info, again, related to pagination. Cursor, related to pagination. Also, strongly typed, as you'll see. Our cursor is a string, and it's a very enthusiastic string because it has an exclamation point. From there, we can continue to our company QL. And this is going to have what our model is showing in SQL Alchemy, which is our ID and our name. It also has the foreign key relationship to departments that we can continue to sort of go through. So, if we click into department QL, we have our ID and our name. And from there, we can go into employees, edges, node, and once again, ID and name. So let's make a query real quick to do that. Let's say we go company edges, node, ID, name. And there's one other field here that I want to point out, which is called type name. That was one of the freebies that GraphQL gives us. And let's see what this returns. So you'll notice that the response from GraphQL is in the exact format that the query was formatted. This is really, really nice for clients because we're not returning, they're not expected to send a request in one format and receive a response in some differing format. They can themselves determine what format they want and how they want their information to be ordered and what fields that they want from these different models. So we can see here that our type name is company QL, and in fact, we can even put type names in between all this as well. Type name, and type name. OK, cool. So let's look at this. So we can see that we go from our root query down to a connection, down to an edge, down to the actual node. Awesome. From here, we can just sort of continue very normally. Say we want to look up departments. And then we go edges, node, ID, name, type name. And then from here, we can go employees, ID, edges, node, ID, name. Cool. So we'll see here that, that the GraphQL response is going to honor the relationship of these different models to one another. So we can see that we'll have one company. That company will have many edges, or many departments rather. So this one company right here, which we have, let's see, we have 2 companies in our query right now. Is that right? Yeah, we have 2 companies in our query right now. And this company, this Marshall Hardy, has departments, which is whatever the heck that is, and some research office and some other fun stuff. Each one of those departments has its own employees as well. So the hierarchy of all of this information is maintained, and once again, it's all in the format that the user queried it. Say we really only want names. We don't really care about IDs. I can just remove IDs from here, and we won't get IDs back. That is extremely flexible, extremely, extremely flexible. Past that, it seems all well and good, right? Like we're getting all this information in half a second. No big deal, easy peasy, call it a day, head out of here. But I don't call it the devil's API for nothing. We need to add a little bit of a delay. The tricky part, one of the caveats with using GraphQL, especially in local development, is that when you're developing on your computer with a local database, you have no time between request and response. There's no network cycle that you're having to deal with to make your queries. So everything is sort of artificially fast. Here, I add 1 millisecond per back and forth over the network to our remote database, to simulate a remote database, rather. And let's see what our query looks like now. Yeah, it's pretty slow. We went from really, really fast to 1 full second for just 3 separate related models. I want to be very clear, this is a really, really small query. These queries get huge, they get nested, they're reusable. So you need to take this into account. Let's head back to our presentation. Nothing went wrong, guys. Oh my God. All right, so the devil is in the latency. As we saw, even small queries can pose some pretty significant performance issues. Local development can be really deceptive because you have a non-trivial request cycle to remote databases. Even if they're both in AWS's servers or something like that, there's still a non-trivial amount of time that those take. So you're asking, why does that matter? And it's all because of our ORM execution event. So that's the fancy term for, hey, database, get me this stuff, and then the stuff comes back from the database. The problem becomes the context of our ladder of GraphQL queries, right? So we essentially have our companies at the top level, then we're running individual queries for each department at each company, and then from there we're running individual queries for all the employees at each department. The equivalent Python code would look like this if you just had a naive GraphQL query. So we have a companies query up top. We're saying for company and companies, do a different query. Then nested within that, we're saying for department and departments, do individual queries. That gets really, really big. And if anybody could guess what that'll be, I don't know, you get a cookie. The math of this gets pretty intense. So in a really, really, really simple model, let's say we have 1 company, 10 departments, and 100 employees. We're looking at about 12 of these events that get fired off over the network. That's no big deal. You don't have to worry about that. That's not going to ruin anybody's day or get them called at midnight, on pager duty. Where it does come into play, say we have 100 companies. At each company, we have 10 departments, and at each department, we have 100 employees. Right? If you're looking at a SaaS platform, this is really small. There, just for 1 query that we ran before, you're looking at 1,100 round trips to the database. That's ridiculous. SQL is super powerful, and it's able to do so much more in 1 query. So we have this sort of imbalance of a very dense query on the GraphQL side that our client is able to use, but natively, or naively rather, there's a very sparse query going to the SQL database, which seems wrong. But alas, there's a fix for this. It's going to be called a data loader. Data loaders ostensibly will batch our requests. So instead of doing those for loops, which we actually still do, we don't run those queries immediately. We run them in a lazy way so that we can batch them across those different levels of context. So the method to do that is by using promises, which will be very familiar to anybody who's programmed in JavaScript in the room. Using these promises, we can create batch load functions, which we'll see shortly. And from there, we're going to do a little bit of performance validation to show just how much faster our API is. So the devil's in the complexity of these data loaders. And it becomes really, really difficult to onboard new people. You have to have a lot of context around your stack. You need to know your database or databases very well to know how to make queries to them that are efficient and that are dense. You need to know your ORM well because especially SQL Alchemy can do a lot of stuff that you're not expecting. It'll run these events without telling you sometimes, which is not great. You also need to know GraphQL core concepts. You need to understand this ladder of context and the complication that comes with that. And last but not least, and honestly the one that keeps me up at night, is Python async, which I have to go to at least, I got to be out of here in 30 minutes for another talk down the hall on Python async. So let's talk about a promise real quick. What the heck is a promise? They're sort of like generators. So what's going to happen is our first step is our resolver, which we saw earlier, is going to say, hey, I need this object. Go and run a query. But instead of running a query immediately, the resolver is going to say, hey, data loader, you do the query. The data loader is going to return a promise to that to the caller, and then at the end, when all of those are done being asked for and they start to be used, they're resolved in a lazy way using this batch load function. So let's look a little bit closer on how we can resolve these promises. They're super simple. I've really looked into them thoroughly. Basically, if we're looking sort of line 196 through 201, we can see we're making a promise. That promise is just an empty promise, like most of my promises. And from there, we can, at some point in time later, resolve the promise. This is a non-blocking call, so we can say, do that 100 times and then resolve them all at once. And then the caller will run promise.resolve or promise.resolve or promise.get rather to see what the promise was resolved with at access time. So that's our sort of like lazy get. And from there, you can see that we get our wonderful string and that it is fulfilled, which all millennials would really appreciate as well. Let's look a little bit closer at the data loader now that we're familiar with what it is. We can see up top we have our class, and that's basically just a shell for our batch load function. This is going to be the meat and potatoes of our data loader. This batch load function gets called with individual IDs or whatever you want it to be called with. It's called with individual ones, but this batch load function will show the collection of them. So that's a little bit of the magic that the promises package does. We go from here to do a nice dense SQL query instead, where we can use our in command to do all of, get all of the departments all at once. And then the crucial part to our data loaders is that we need to pack and unpack this result so that it's in the same order that it was called with. So this company's ID at line 164, that's going to be in some random order. We can't assume it's ordered by ID. But the response in promises.resolve down at 180, that needs to be in the same order, or else the callers will get junk, basically. Generally, I like to do this with default dictionaries that take a dictionary of lists. They're pretty quick to load up, and they're pretty quick to pop. So there's not a big performance implication there. A couple caveats. This is the simplest data loader you're going to see. They get really big, really hairy from here. The promise.resolve, again, needs to be in the same order as the method argument. These optimizations are directional. So this one specifically, right, we're loading departments, and this is coming from companies. So we have company IDs as our method argument, and we have department data loader. So if we go companies to departments, this will get fired. If we go department to companies, this will not get used, and we won't have the performance optimizations. Last but not least, we need to include filters in here for the real world. This one doesn't include filters. It adds a little bit of complication, but it's not too bad. Really, you just end up having to write a lot of flexible SQL queries with if, ands, and such. All right, let's go see our data loader gains. Keep your fingers crossed, everybody. This is going to be demo number 2, and if this goes well, but I'm gonna go get a lottery ticket. All right, so I very cleverly have this use data loaders. This is what you're going to want in your app whenever you show your boss that you made a giant speed up. So we can see our previous query down here was 1.05 seconds. Let's run this exact same query. Now we're down at 400 milliseconds rather. So we've halved the amount of time that query takes. But like I was mentioning before, let's look at a backwards query. So if we query backwards query, and we go from employees, edges, node, ID, name, and we go up to departments, ID. You can see here too that the edges and nodes, again, are how the schema dictates them. It's not bidirectional. That's unidirectional how that schema is set up. So if you want it to be edges and nodes both ways to allow for pagination, you need to specify that. From here, we can go companies, ID, and name. So if we query this, we're even worse than we started. We're now at 1.4 seconds. This is running a ton of queries. We're looking at, our resolvers are getting hit 600 times. And that's just too much. But if we come back here, we can see that despite our resolver getting hit now, it's 200 times per, our data loader only gets called once. So that's how we see that we're batching. So just to clear that number, because I very lazily didn't have them clear per transaction, we can see that a resolver gets called 200 times, but our data loader only gets called once. That means everything's batching and everything's A-OK. All right. So now that we're hopefully doing OK on time, let's talk about some key takeaways from our talk. This is the good. GraphQL has a lot of good to it. It's super descriptive, very explorable, very friendly to your users. You get only the attributes you need, so if there are some attributes that take a lot of computation and maybe shouldn't be accessed hopefully as much as others, your clients don't need to request those, especially if they don't need them and you're not wasting compute cycles. The queries are really dense. You're not running a bunch of queries like you would have to in a REST API to do like follow-up queries on your initial one. So this can reduce the amount of queries per second on your API, and it can shift the load from having to parallelize Python and do a bunch of like fancy stuff in Flask to allow for a bunch of requests incoming to maybe your database who's used to serving a lot of GET requests. It can be very performant when optimized. I mean, we could see, it's running a decently large query and it's returning thousands of lines of JSON in about half a second. And data loaders aren't that bad in the grand scheme of things. I mean, I've seen a lot worse, especially as we start to get into like, your ops pipelines and stuff. Whew, it gets very complicated. They are easily parsable return types. They're in the same format that we query that we query GraphQL with. Pagination's built in. That's a total freebie, and that is something that is amazing. You should definitely use it if you have large responses. Past that, all of our types are strongly typed in the schema, and they're documented as being strongly typed. And our root node makes auth easy because all of our users have to come through one place. The bad. GraphQL servers can add significant complexity to your backend development lifecycle. I do think that they have slowed our development process a bit, and it makes onboarding new employees kind of difficult. I mean, it's a lot of concepts to pick up all at once, especially if you're expecting that from a younger engineer. Software queries, or simple queries rather, can slow performance. So something to be aware of, and the directionality of your queries can also affect your performance. So you need to know how your users are using your API, or else you can really get bit. It can expose our M+1 issue, our M+1 queries issue to the user. This isn't new. You can still have an M+1 query issue in a RESTful API. This just makes it maybe a little bit easier for the users to hit by accident. Deep knowledge of the underlying database and GraphQL structure and contexts and async is crucial to making your APIs work quickly and reliably. And versioning is fuzzy. In my experience, if you have new stuff that you can send, you just kind of like add a new attribute, or maybe you can make a query parameter for that node saying you want version 1 or version 2 and make that required. But it seems non-standardized in my understanding. So something to keep in mind if, maybe if you're at like a public company with a very highly utilized API. When to use GraphQL? I think you should use GraphQL. I think it's a really cool technology. If you're prioritizing a great user experience, if you want your clients to have a great time going through your API, if you want things to be discoverable and explorable and friendly, GraphQL is a great technology for that, and it's something that REST really didn't provide. Especially if you had bad documentation for your REST APIs like everybody does because their Swagger docs are 100 years old. If your API is getting bogged down with too many queries per second, GraphQL can give you denser queries, and that's a real lifesaver. If you're trying to deprecate some old APIs, or you want to put a facade over your databases so that you don't have to expect your user to know your database architecture or infrastructure. You just want them to be able to query things. GraphQL can make that facade, and it'll be really, really easy and sort of end-to-end pretty. Past that, if you crave a challenge in your life and you want to make more data loaders and learn all about async stuff, why not? It's great for job retention. Last, we at Tatari have put out an open source tool that can help you determine if you've got an n+1 query in your API. It's called Query Counter. It hooks into SQL Alchemy sessions, and it'll give you some nice logging output. You can send that straight to dev null, and it'll be web scale. It's incredible. One of our engineers, Brian Olecki, did that. He's a really, really great engineer, so I'd recommend downloading and giving him a bunch of thumbs up or stars on GitHub. Past that, I got to do my shout-outs. Thank you to Tatari for supporting me through all of this. I took a bunch of hours that I should have been working to work on this presentation, as I'm sure you can see. It was really great, wasn't it? And check them out. Check them out in the expo hall. We're sort of towards the back, next to the BMW. And we'll be at the career fair tomorrow. We're always hiring engineers, data scientists, engineering managers, and we have 2 or 3 classes of interns per year that come through. I also wanted to thank these individuals. In specific, David Hu, he's the one who got all this Python nonsense together. He got the cats herded, and we were able to get an abstract in on time. I wanted to thank Song Chang for putting for organizing everything. The Bay Piggies meetup, please go to that one. It's fantastic. I was able to test this talk out there, and to a couple others who have helped me tremendously along the way with this. And join me in some tech talks, Again, Bay Area Piggies is awesome. That's like a monthly meetup. I run the Homebrew Learning Club. We do a couple of different events related to Python or really just continued learning and academia. And SoCal Python meetup as well. So we got sort of East and West Coast. And that's all for me. You've been a wonderful audience. I can't thank you enough.